Hello, Maurits here. Today we will talk about the law of gravity and the mass of the Earth. So, Newton's law of gravity. Basically, that has the same form as Coulomb's law. So, a constant, we call that capital G, times the mass 1 times the mass 2 over r square. We often see this as written as G m capital M over r square, where G is a particular constant. We can also write this in terms of gravitational acceleration, and since we know that force equals mass times acceleration, we have that acceleration is force divided by mass. So we could take this formula and divide by the mass, and we get that the acceleration equals to G capital M over r square. That also allows us to figure out the unit for this constant, since we will get that G equals to a r square over m, and that will give us the unit meters per second square for the acceleration, right? Times r square, which is meters squared over kilograms, or the rather strange unit, cubic meter per kilogram per second square, which doesn't make any real sense, but that is anyhow the unit we will get. The value of this constant can be found by an experiment, was initially found by an experiment called the Cavendish experiment. We can do a lot of other experiments today to figure this one out, but through experiments we can find that that G equals to approximately 6.67 times 10 to the power of negative 11, then the cubic meter per kilogram per second square. Okay, now we should use this to figure out the mass of the Earth. Okay, so what to do now? So say we are standing on Earth somewhere, and the r there is the distance from the center of one of the masses to the center of the other, at least if they're spherical. And on this scale, this size of u doesn't really matter. And anyhow, we can use with this formula, we only care about acceleration. So we have that acceleration is g m over r square. And acceleration in this case on the surface of the Earth will be small g, right? So that means that we can make m our subject, so we get m equals to g r square over capital G. And these are different all the time. And if we Google for the radius of the Earth, we will find that average radius is 6,371 kilometers, or 6.371 times 10 to the power of 6 meters. So now we can just fill this into what we have and find that the mass of the Earth equals to 9.81 times 6.371 times 10 to the power of 6. This should be squared over the constant that we know then is 6.67 times 10 to the power of negative 11. So that comes the calculator. And let's do the calculations. 9.81 times bracket 6.371 x6, and then square divided by 6.67 x negative 11, and out pops a mass of 5.97 times 10 to the power of 24 kilograms. And that is what we also can find if we go on Wikipedia and so on, look at this. So with this number of figures. So we found out the value quite accurately. We were a bit lucky here because we used the average radius and so on. And we used average G, which will help out because the average radius and the average G will be at the same places, basically. So that works out fine. Does this number make some sense? We can do a little Fermi calculation and say we have the Earth here, and I will put the Earth into a big, not totally into, but a big cube. So we know the diameter is about 12 times 10 to the power 6, so about 10 to the power of 7. So say we make a big cube of this. The Earth will stick out a little bit, on the other hand it will be inside there. So if you take, each side will take 10 to the power of 7, we take that to the power of 3, and that will give us a volume approximately of 10 to the power of 21 cubic meters of the Earth. And we know the Earth consists mainly of rock and particularly towards the center iron that has a mass closer to 10 kilos per liter, or in other words 10,000 kilos per cubic meter. So if we take 10 to the power 21 times 10 to the power of 4, that is 10,000, will give us 10 to the power of 25 kilograms, which fits rather well. So by the Fermi calculation we say that can see that this makes sense also. So we have figured out the mass of the Earth from the law of gravity. That's sort of cool. Ciao.